All right. Welcome back. This is part two of the first lesson on geometric vectors for Precal. Finishing up question number 6. We were able to add and break down each of the vectors RS and negative U. We were subtracting it together into their vertical and horizontal components that we have drawn over here. So we do have each of our horizontal components and each of our vertical components represented with y values. All right, so now that we have those, if you add all of your x values together, the sum of the x or horizontal values added together should equal negative 3.43. And the sum of the y values should equal approximately 4.504. So if you draw an x value of negative 3.43, a y value of 4.504, positive y, so we can figure out what the resultant vector is going to be. So my guess is a little bit over 5 and somewhere between 90 and 180 degrees from the standard position. So it should be somewhere around 133, looks like the only answer choice, and obviously answer choice A does do that. If you do Pythagorean theorem here, you do end up getting 5.4 approximately, and I think it's 129 point something degrees that rounds up to 133, so it does end up being answer choice A. All right. For question 7 here, I've already drew a nice diagram. If you haven't already tried this one, this is a pretty easy one, so don't just get the answer or try this one on your own. See if you get it, come back if you don't. We have a piling here that has a couple of bulldozers pushing on it. The first one is pushing in a west direction, 1,850 pounds. The other one is pushing in the north direction, 3,250 pounds. And it asks, what is the magnitude of the resultant force? So all we have to do is add these two forces together and figure out what the magnitude is. So if we add these two forces, we have our 3,250 right here, added to the 1,850. So 3,250, 1,850, we get the green resultant vector here. If you do Pythagorean theorem, 3,250 squared plus 1,850 squared equals, I don't know, let's call this R. C, I guess it doesn't really matter. Take the square root of both sides and you can plug that in your calculator. And I think you get 37, 39 point something. Oops, not point. That doesn't make a whole lot of sense. 0.6, I don't know exactly what it is, but it does round up to 40, and it does ask for the nearest 10 pounds anyway, so it would be 40, even if it was 37, 35 something, just because it should round up to the nearest 10 pounds. So 3740 is what we end up getting. All right, for number 8, we have the exact same problem, except for this one is asking what is the direction of the resultant force. So on this one, we just need to use trigonometry to solve for the angle, and then you can do it either from the standard position, or you could use the north, east, south, and west axis to describe the direction. So if you wanted to figure out, let's say, this angle in the triangle right here, we could use the opposite and adjacent sides, so we could use the tangent ratio. Oops, right here. Equals opposite over adjacent. Oh, that was right. 1,850 over 3,250. And then to solve for the angle, we just need to do the tan inverse of both sides. which I haven't calculated yet, but I think we end up getting 30 degrees. Or approximately 30 degrees on that one. Let me check real quick just to make sure that is what we get. Obviously, you would want degrees for this one. If you're using your calculator again, make sure it is in degree mode. So tan inverse 1850 over 3250. We get 29.649, so that is approximately equal. All right, so to describe this angle, we could do this in a couple of ways. We could say it's 90 degrees plus 30 more degrees to get our triangle that we created right there, so 120 degrees. Or you could say that it's 60 degrees north of west, which is the answer we have down here. So 60 degrees north of the west direction is a way of describing it. 30 degrees west of north. You could do that. That would also be correct. Just pick one of the axes and say how far away from it to the left or right, east or west, or north or south that you're going from it. So 30 degrees north of the west axis, 60 degrees west of the north axis, or 30 degrees west of the, what am I saying here? North of the west axis or west of the north axis. All right. For this one, interesting concept. I don't really use this one too much, but they have in the video instruction that they give you before the practice questions, it gives you a parallelogram method of determining resultant vectors. If you have a couple of vectors and you want to add them together and find the resultant vector, you can create, one way is just a triangle method. You literally add them end to end, like we did A and B right here, and you get the resultant vector by drawing the triangle. Another way is called the parallelogram method, which is if you draw a parallelogram using two A's and two B's, we get this parallelogram that we have right here. And you'll notice that the original diagonal is there, but I didn't draw it. I drew the other diagonal. And what is that other diagonal? That's what the question is asking, if you connect the other two terminal points. Well, here, the third thing, you'll see I drew the same diagonal, but I drew it with the original A value, but instead of going this direction for B, I did the opposite of B. And the resultant value that we get, this diagonal, is the same as this diagonal, same direction, same magnitude, everything. And that is just A minus B. That's just the difference of them. So adding the two together, you get one diagonal. If you subtracted A minus B, you'd get the other diagonal, which is these two pieces right here. So one diagonal represents A plus B, the other diagonal represents A minus B. So ultimately, it's asking what does the other diagonal represent? It represents the difference of the two vectors. All right, and last one, interesting problem we have here. I do this one in my geometry class, so it shouldn't be too hard. You just need to draw a nice diagram. So I drew one here. It says Don's friend Melissa lives 3 blocks west and 4 blocks south of Don. So here I drew Don, and 3 blocks west, 4 blocks south, I drew Melissa. It also says that Caroline lives 5 blocks east and 1 block north of Don. So then it asks how far do Melissa and Caroline live from each other. You just need to find the total east and west values and then solve the distance between them. So you'll notice here the total east value is 8. The total north or south value is 5. If I draw this and turn it into this triangle right here, you end up getting a right triangle with legs of 8 and 5. You can do Pythagorean theorem to solve for the hypotenuse and Pythagorean theorem you guys can do, you do end up getting 9.4. A squared plus b squared equals c squared. Approximately, if you round it to the nearest tenth, you should get about 9.4 blocks from each other. Now, in all honesty, you could say that's how far the distance is, but if you were walking there, you couldn't walk straight there. You'd have to walk on the blocks. You'd actually have to walk 4 plus 3 plus 5 plus 1. So you'd actually have to walk a total of 13 blocks if you were walking there. Just an interesting type of question I pose to my geometry kids. What's the actual distance and how far would you have to go if you were walking and you didn't cut across diagonally any fields? Two different types of questions. All right, I hope that clears some stuff up for you. I'll be posting the algebraic vectors here within the next hour or so. If it's not up when you start this video, check it afterwards. It should be up.